All right, this is 8th grade, lesson 24, module 4, on Introduction to Simultaneous Equations. So now we're going to start to learn how to solve equations. When you have two equations, you need to solve at the same time. So we're going to start off kind of as a review of what we've been doing, where we had an equation with two different variables. So we're going to look at this table here. It says Derek scored 30 points in a basketball game he played, and not once did he go for the free throw line. That means that Derek scored 2-point shots and 3-point shots. List as many combinations of 2 and 3-pointers that you can that would total 30 points. All right, so let's start to think of a couple here. Let's start with an easy one. What if we just did 15? I know that 15 times 2 gives me 30, so I don't need any 3-pointers. And since I have a 0 in the y column, let's try a 0 in the x column. If I shot no 2-pointers, then how many 3-pointers did I shoot? 10, because 10 times 3 gives me 30. All right, what if I did 12 2-pointers? So we have 12 times 2 gives me 24. Now I need 30. So if I did 2 3-pointers, that's 2 times 3 gives me 6, and 24 plus 6 gives me 30. All right, what if I did 9 2-pointers? 9 times 2 gives me 18, which means I would need 4 3-pointers. That's 4 times 3, which gives me 12. And 18 plus 12 gives me 30. All right, how about 6? 6 2-pointers gives me 12. 6 3-pointers gives me 18. So again, 18 and 12 is 30. Let's try a last combination. We have 3. 3 times 2 is 6. So I would need 8 3-pointers because 8 times 3 is 24. All right. So we could sit here and guess and check all day long. Now, I'm pretty sure if I asked you guys to come up with your own numbers, it would have taken you a lot longer. And that's because coming up with numbers off top of your head can be very hard. That's why writing equation makes it a little bit easier. So a 2-pointer is 2 times a number. How many shots were thrown that counted as 2 points? Plus the 3-pointers, again, how many shots were taken that were 3-pointers? And when I add those two up, I needed it to equal 30. So now if you were to take one of these numbers and plug them in, it would make a lot more sense as far as how to get the answer. So you're not just randomly thinking of numbers off the top of your head. All right, let's go ahead and go on to the next problem, number 2. All right. Derek tells you that the number of 2-point shots that he made is 5 more than the number of 3-point shots. How many combinations can you come up with that fit that scenario? All right, so this number over here needs to be 5 bigger than this number. So 5 more than that. All right. Well, what if I said 6? Well, that's 5 more, so 6 take away 5, he would shoot 1. How about 7? All right. Well, 7 take away 5 gives me 2. How about 8? 8 take away 5 gives me 3. All right. What about 9? 9 take away 5 gives me 4. How about 10? 10 take away 5 gives me 5. And how about 11 gives me 6? Well, again, writing an equation can make this a little easier than thinking of numbers off the top of your head. So we're going to say the number of 2-point shots, is equal to 5 plus whatever the y was. So if you think 1 is y, so that's 1 plus 5 gives me 6, and the 6 represents the x. All right, which pair of numbers from the table in exercise 2 would show Derek's actual score of 30 points. So what was his actual score? Well, let's put it this way. Look on this table and look back at your other table. Do you see a combination that repeated? I'll give you a second to look. All right, you should have saw 9-4. The 9-4 repeated in both scenarios. So that's actually what he did. So we're going to say 9-4 shows Derek's actual score of 30 points. All right, let me try 4 with you. Let me pull this up. Efren and Fernie are on a road trip. Each of them drives at a constant speed. Efren is a safe driver and travels 45 miles per hour for the entire trip. Fernie is not such a safe driver. He drives 70 miles per hour throughout the trip. Fernie and Fern left the same location, but Efren left at 8 a.m. and Fernie left at 11 a.m. Assuming that they take the same route, will Fernie ever catch up with Efren? All right. So what we're going to do here is write down some information that we have. We know that E, we're just going to shorten it to E, traveled at 45 miles per hour. And his buddy down here, he traveled at 70 miles per hour. All right. So this one here says to write an equation to represent E's speed. So he is y equals, and his constant is 45. Remember, your constant always goes in front of x. But he took an additional 3 hours because, see, he left at 8 a.m. and his friend left at 11 a.m. So he has 3 extra hours. So what we're going to do is say y equals his constant times x plus that additional 3 hours. So there's his equation. Now, of course, we'll simplify this more a little bit in the next step. Now, Fernie, he did 70 miles per hour. He didn't have any additional time. So he's just y equals 70x. All right, let's go on to the next question here. C. Write a system of linear equations that represent this situation. Now, this is where we're going to start to get into solving 2 equations at the same time. And that looks like this. We have E's equation, which is y equals 45x plus 135. And how I got that was I simplified. We had y equals 45 times x plus 3. And what you do is distribute that 45 to both, and you wind up with this. All right, and then we have F's equation, which is y equals 70x. Now, when we're talking about systems of equations, we bracket them like this so we know that the 2 go together. So what I'm going to do is I'm actually going to graph these 2 lines here. All right. Now, we know here that E, his slope is 45, and he started at 135. Okay. But these are kind of broken in by 100. So I would say 135 is probably right about here. So that's where he crosses the Y line. All right. Now, obviously, we're not going to be able to count a true 45 here. But what I can see is that he had 3 additional hours. So he didn't start at 0 like F did. He started 3 additional hours. So I'm actually going to come back 3 hours and put a dot right there. All right, so you're going to kind of connect these 2. And I want you guys using a straight edge. All right, and we're going to label that E. Now I'm going to do F's line. All right, now he does start at 0. And he has a scale factor or slope of 70. So I'm going to say 70 is right about there. Okay. Now he is up 70 over 1. So he's actually right about there. So we're going to do a line here. I'm going to try my best to try and line those up. I'm not doing a very good job there. All right. Now, if you did this perfectly and you have a nice straight line, you would actually see that they collide actually right about there. My line isn't perfectly straight. So what is that point? That point is going to be, oh, my lines are way off. All right, let me try that again. Let's try this again. All right, so we have this, and we had 135. All right, I actually know the point of intersection here, so I'm going to try and help myself out. It's 4.5 and 325. So it's right about, all right, we'll make it right about there. My lines are not straight, but I'm trying to use the best I can do here. All right, and then we had 71 and 0 here. All right, so it should be something like that with nice straighter, much straighter lines. So you can see that the two gentlemen did meet up at one point, okay? And then F definitely took over where E kind of stayed his constant slower speed. So the question here is, will they ever catch up? And we're going to say yes. At about 4.5 hours, or you can say 325 miles. So what is that coordinate point? That coordinate is 4.5 and 325. Those were the coordinates that this collision took place. Hopefully they didn't actually collide. That's just where they intersected. All right, let's go on to number 5. All right, now number 5 is very similar to the one we were just doing. So I'm going to set it up, and then I'm going to let you guys finish this one up. So it says Jessica and Carl run at a constant speed. Jessica can run at 3 miles in 24 minutes. Carl can run at 2 miles in 14 minutes. They decide to race each other. As soon as the race begins, Carl trips and takes 2 minutes to recover. So write a linear equation that represents Jessica's constant speed. All right, so this one's going to be for Jessica. So we're going to first write her rate. She's going 3 miles in 24 minutes. Now I can reduce that down to 1/8, which is 1 mile in 8 minutes. So her equation would be y equals 1/8 x. All right. Now she actually had 2 additional minutes because Carl tripped, and so she kind of gained 2 minutes. So we're going to say y equals 1/8 times x plus 2. So in the end, final equation for Jessica would be y equals 1/8 x plus 1/4. So that's the equation we're going to use for Jessica. All right, now let's talk about Carl. Carl's rate is 2:14, so 2 miles in 14 minutes. All right, we can simplify that down to 1 mile in 7 minutes. All right, so what his equation comes out to y equals 1/7 x. Now, since we already gave the 2 minutes to Jessica, we just leave it like that. So my systems of equations here, ooh, what happened there? My pen stopped working. Let's try that again. All right, here we go. There we go. We're going to put the 2 equations on top of each other. I'm going to box that one real quick. All right, we have Jessica at y equals 1/8 x plus 1/4. And then we have Carl at y equals 1/7 x. All right, so what you're going to do is graph, and you're going to tell me where they intersected, if they intersected. And then the next page on the back here asks us who would win a race if it was only 3 miles long. It would be Jessica or Carl. And approximately what point did they tie? So in other words, where did they meet? So these lines will cross at what point? All right, that finishes this tutorial.